Good morning and welcome. On this stand today, myself, Rachel Taylor and Mark McGee are going to outline the performance targets of suckler calf and dairy calf to beef systems, along with the consequences, both environmental and economic, of not achieving these targets. However, before we discuss the calf to beef performance targets, we need to attain a calf. On a suckler beef system, the primary output of the suckler cow is the calf, so there are a number of reproductive targets that we need to achieve in order to maximise the output from our suckler herd. First of all, we have the 24-month aged calving. By achieving this, we're going to maximise the production potential of the suckler cow and increase her productive lifespan within the herd. Then we have 0.95 calves per cow per year. This is going to be achieved by minimising empty rate and mortality rate below 5%, as well as attaining a 365-day calving interval. Thirdly, we require an 80% of the cows to calve within 6 weeks of age. This will not only ensure that we have a uniform batch of calves at weaning that are as old as possible, but it also allows the cow the optimal length of time for her to return in calf and calve again within 365 days. And finally, excellent genetics. Not only do we want our cow to have good fertility genetics, but we also want her to have a high milk yield so that she can wean a healthy, heavy calf at weaning in the autumn. On the dairy calf side, we're reliant on purchasing calves. So there's two main areas that we're looking at. Firstly, we're looking at the high commercial beef value. While there's little we can do about the dam genetics of our dairy calves, the sire genetics can alter the performance targets of these calves greatly throughout their life. So therefore, selecting calves with a high dairy calf beef index is critical to good performance. And the second element is health. Not only do we want calves that are healthy, bright and lively when we buy them, but we also want calves that have received adequate levels of colostrum so that they have a strong immune system to give them a defence against pathogens and diseases that they're going to face. So once we have our calf, we look at the first grazing season, or the first 8 months of life of that calf. This is the only real period in the time of the calf to beef system that varies greatly between the suckler calf and the dairy calf. For the suckler calf, the first 8 months are largely comprised of a milk-based diet as the calf is suckling the cow. During this time, we ideally want the calf to achieve average daily gains of 1.2 kilos per day, which in the winter will result in a live weighted housing of 315 kilos approximately. Prior to housing, a couple of weeks before they enter the shed, we want to incorporate about 1 kilo of concentrates into the diet of this calf to minimise the stress at weaning for the calf and also to reduce its dependence on the milk diet. So therefore we are gradually introducing it to its winter diet. In terms of the dairy calf, the first 8 months can be divided into relatively two sections. Firstly, approximately the first 8 weeks of life, where the calf is being artificially reared on milk replacer and concentrates at about up to 1 kilo per day. During this period, ideally the calves would be gaining 0.17 kilos per day. Around mid-May time, calves will then be turned out to grass. Concentrates will slowly be reduced as they acclimatise to the grass-based diet, and up until housing, they should target a live weight gain of 0.8 kilos per day. Concentrates will be gradually introduced again prior to housing, similar to the suckler calf system, so that they're starting to acclimatise to the winter-based diet, and at housing calves should be 220 kilos roughly in live weight gain. During the first winter, average daily gain will be similar then for both the suckler and the dairy bred calf. We want them to gain 0.5 to 0.6 kilos per day on a silage-based diet with 1 kilo of concentrates over the winter, which is approximately 120 days. At the end of the winter period, these animals should aim to be at a live weight of 380 kilos live weight for the suckler bred calf and 290 kilos live weight for the dairy bred calf. They then turn out to grass as early as possible for their second grazing season, at which point we shall see higher levels of growth off a grass-only based diet due to the compensatory growth of having been on a restricted energy-based diet the previous winter. They should attain live weights of 0.9 to 1 kilos per day throughout this grazing season. Within the second grazing season, we're also faced with two options. One, we can finish heavier, more early maturing cattle off grass in an 18 to 20 month finishing system, or secondly, these calves can head back into the shed for a second winter. If these animals are being finished off grass, depending on the supply of grass and also the genetics of the animal, with later maturing animals probably more likely to need some concentrate supplementation, moderate levels of concentrates at 3 to 4 kilos per day may be introduced in order to finish these animals and for them to achieve a fat score of 2+ to 3-. Finishing animals should be, for the suckler bred system, a live weight of 620 kilos, which will result in a 340 kilo carcass, and for dairy calves should be 530 kilos, which will result in 280 kilo carcass. If these animals are going to return to the shed for a second winter, we would like them to be at a live weight of 580 kilos at housing and 500 kilos for the dairy calf at housing. In the shed for the second winter, we're once again posed with the option of finishing these cattle in the shed at a 22 to 24 month system, or store them over the winter period where they'll return out to grass for a third grazing season. Within the finishing system, these animals will receive silage plus moderate levels of concentrates at 4 to 5 kilos per day, which will attain average daily gains of 0.9 to 1.1 kilos a day. These animals at finishing should aim to have a live weight of the suckler bred calves of 675 kilos and for the dairy bred calves 585 kilos, resulting in carcass weights of 385 and 305 respectively. If the animals are going to return to grass for a third grazing season, we just want to store them over this winter period once again so that we can take advantage of compensatory growth when they return to grass for the third grazing season. In this case, we want to restrict their energy in the diet again, so we're talking about feeding silage and, if needed, 1 kilo of concentrate so that they achieve just half a kilo per day live weight gain. These animals at turnout should be in approximate live weight of 640 kilos for the suckler bred and 560 kilos for the dairy bred animals. They then return out to grass where they should experience extremely high levels of average daily gain due to the compensatory growth, so therefore they should be achieving 1.1 to 1.5 kilos per day for a short grazing season of approximately 3 to 4 months so that they'll finish under 28 months of age. This will result in them finishing at approximate live weights of 730 kilos for the suckler bred animals, leaving a carcass of 420 kilos, and 670 kilos of live weight for the dairy bred animals, resulting in a 335 kilo carcass. So now the question we ask ourselves is, what are the economic and environmental consequences of not achieving these targets? So I'll hand it over to Mark to...
Thanks, Rachel. Okay, the objective of this board is to look at the consequences of not meeting targets on the percentage change in profitability expressed as net margin per head, that's in the green bars, and on the percentage change in greenhouse gas emissions per kilogram, either live weight, where we're selling live animals, or per kilogram carcass, where we're bringing the animals through to slaughter. To look at we're looking at the effect of this in the context of systems outlined on the first stand you saw this morning. Namely, we're looking at our suckler calf to weaning system, a spring calving herd producing weanlings at 8 months of age. We're looking at a suckler weanling to beef system, again, purchase weanlings being brought through to slaughter and finished at the end of the second grazing season at about 21 months of age. We're also looking at a dairy calf to beef system. The purchased dairy calf is again brought through to slaughter at the end of the second grazing season at about 20 months of age. So that's the context for the implications. Firstly, the KPIs are the performance indicators that we're looking at within the suckler calf to weaning system. Firstly, we're looking at increasing age at first calving, so we're going from 24 up to 36 months of age. We're also looking at reducing calving rate, going from 96 down to 91%, and we're also looking at increasing calf mortality, going from 4.1 up to 8.6%. We're also looking at the effect of reducing grazing season length by about 1 month. In other words, turning animals out to pasture, say on the 1st of April versus the 1st of March. In all cases, we find that not meeting our KPIs results in a reduction in profitability and an increase in greenhouse gas emissions. And the magnitude of this effect is greatest for increasing the age at first calving, again emphasising the importance of the high overhead cost of having unproductive animals on the farm. So a substantial increase in the percentage change in profitability and a large increase in the percentage change in greenhouse gas emissions. When we move on to our suckler weaning to beef system, again we're looking at the effect of increasing calf mortality, in this case going from 0.9 up to 4.4%. We're looking at the effect of reducing grazing season length, again by about 1 month. Additionally, we're looking at the effect of reducing average daily gain by about 8%. That's equivalent to about 75 or 80 grams per day during the main grazing season. We're also looking at the effect of increasing slaughter age by either 1 month or 2 months. In the case of the 1 month, we're still able to finish the animals off pasture, whereas in the case of increasing slaughter age by 2 months, we must house the animals indoors and finish them on grass silage plus concentrates. Again, similar to the suckler calf to weanling system, we find that for increasing calf mortality, reducing grazing season length, and also reducing average daily gain, not meeting our KPIs results in a negative impact on profitability and an increase in greenhouse gas emissions. In terms of increasing slaughter age by 1 month, where we're still able to finish the animals off pasture, we find it actually increases profitability and there's a corresponding small increase in greenhouse gas emissions. Now this emphasises the importance of a low-cost diet. In this case it's grass-based in terms of driving profit on beef farms. However, when we have to hold the animals for an additional 2 months, increase slaughter age by 2 months, which results in the animals having to be housed indoors and offered grass silage and a high concentrate or a moderate level of concentrate supplementation, we find a substantial reduction in profitability and a corresponding large increase in greenhouse gas emissions. Similarly, for our dairy calf to beef system, again we're comparing calf mortality, in this case 5.9 versus 10%. We're looking at the effect of reducing grazing season length, somewhere in the order of a month, and again increasing slaughter age by either 1 month or 2 months. And in this case we can still finish the animals off pasture, whereas in this case 2 months we must house the animals inside, and again they're offered grass silage and supplementary concentrates. Similar to the suckler system, we find that not meeting our performance targets in terms of calf mortality or grazing season length results in a reduction in profitability and an increase in greenhouse gas emissions. Again, where we increase slaughter age by 1 month on a grass-based system, we get an increase in profitability and a corresponding increase in greenhouse gas emissions. However, when we have to house the animals inside, essentially we break even in terms of profitability and we get a correspondingly large increase in greenhouse gas emissions per kilogram of carcass. So overall we can see that there's a general negative or inverse relationship between profitability and greenhouse gas emissions. And in terms of meeting our national targets, this can be viewed as a win-win. So overall, what are our take-home messages? Firstly, we got to know the targets as outlined by Rachel. We have to have some idea of these numbers. Secondly, we must monitor performance in order to see are we actually achieving the targets. For growing cattle, this means regular weighing of animals to see are we meeting these live weight gain targets and corresponding growth targets at key stages. Overall, we find that increasing performance results in increased profitability and reduced carbon footprint. So again, we have a classic, I suppose, win-win situation in terms of meeting our national targets. How do we achieve these targets? Essentially that will be dealt with on the next stand and during the various stands throughout the villages at today's open day.